Welcome to Science for Sleep. Tonight, we embark on a journey so vast, so ancient, that it reaches beyond the dawn of creation itself. You're about to hear a story not of our civilization, or even of our universe as we know it, but of the faintest whisper of light older than time itself. As you close your eyes, let your mind drift into the endless depths of space. The James Webb Space Telescope has just seen something extraordinary, light from before the beginning of everything we've ever known. It sounds impossible, doesn't it? How can light exist before time began? How can something emerge before the moment all existence was born? Yet, deep in the cosmic darkness, Webb's golden mirrors captured something that defies logic. A faint, ancient glow, older than the Big Bang as we understand it. What if time, that steady ticking river we trust so much, had a secret it's been hiding? What if there was something before the beginning chapter of creation? To understand this mystery, we must first go back nearly 13.8 billion years, to the moment when everything we know burst into being. The Big Bang wasn't an explosion in space, it was the expansion of space itself. Imagine the entire universe compressed into something smaller than an atom, then expanding outward in a flash of unimaginable energy. For centuries, that moment was considered the absolute beginning, the point where both space and time were born. Nothing existed before it, or so we thought, but science has a way of challenging its own limits. Every discovery leads to more questions, and James Webb is humanity's latest tool for peeling back the cosmic curtain. Launched into the silent void, Webb is not just a telescope, it's a time machine. Its infrared eyes peer through dust and darkness to capture the oldest light in existence, light that has been traveling for billions of years just to reach us. Every photon Webb records is a message from the past, a story written in the language of starlight. A few months ago, when Webb pointed its gaze toward a faint, distant region of the cosmos, scientists expected to see early galaxies, tiny, newborn clusters forming shortly after the Big Bang. Instead, they saw something that shouldn't exist. The light Webb detected was far too redshifted, far too ancient. Calculations showed it didn't just come from 13.5 billion years ago. It seemed to come from before time, before the moment our universe began expanding. That's when the impossible question arose. What could possibly emit light before time began? Some scientists speculated a calibration error. Others proposed gravitational lensing, a trick of cosmic magnification. But after repeated verifications, the data remained stubbornly consistent. The light was real. It came from somewhere beyond our cosmic horizon, a whisper from a realm that predates the known universe. As we listen to this, imagine floating in the vast darkness of intergalactic space, watching a faint glimmer appear in the distance, like an ember glowing in a cold, infinite ocean. To make sense of this, cosmologists began revisiting some of the most mind-bending theories ever conceived, ideas that suggest our universe might not be the first. Perhaps the Big Bang wasn't the beginning, but a transition, a bridge between two cycles of existence. In one model, the universe undergoes eternal rebirths, each Big Bang following a big crunch in an endless rhythm of creation and collapse. If that's true, then the light Webb detected might be a ghostly remnant from a previous universe, the last heartbeat of a cosmos long gone. Others offer a different explanation. The light could be an echo from a quantum field that existed before time had meaning. Imagine a sea of energy, timeless and infinite, fluctuating and collapsing until one fluctuation became our universe. If so, Webb may have caught a glimpse of that primordial chimera glow from a realm where physics as we know it breaks down. The thought is both terrifying and beautiful. Our universe may not be alone. It might be one bubble among countless others, each with its own laws, its own time, its own beginning. As you listen, let your breathing slow. The universe has no rush. Time stretches endlessly here. Think of those photons, tiny messengers of light traveling across billions of years, across collapsing stars, galaxies, and cosmic dust, just to reach a small blue planet orbiting an ordinary star. And on that planet, a species built a telescope, pointed it upward, and for the first time saw a trace of what came before existence itself. It's humbling to realize that the light now resting in Webb's sensors began its journey before there were stars, before there was space, before there was anything at all. Even more fascinating is what this discovery means for us. If there truly is light older than time, it challenges the very foundation of physics. It suggests that time is not absolute, that it can bend, stretch, or even emerge from something deeper. Perhaps time is not a river, but a wave, rising and falling across the surface of an ocean we can't yet see. And somewhere beyond that horizon, another universe might be stirring, preparing for its own beginning. So as you close your eyes tonight, imagine yourself standing at the edge of that ancient light, watching it fade into the distance. You are looking not just into space, but into eternity itself. The James Webb Telescope didn't just find light from before time began, it found a reflection of our deepest question. What came before everything? Maybe, just maybe, that answer lies not in equations, but in the quiet wonder that fills your mind as you drift into sleep. The story doesn't end there, because once Webb saw that impossible glow, something even stranger began to happen. Across multiple observation sessions, faint but consistent fluctuations in background radiation started appearing in directions that didn't align with any known galaxies or cosmic microwave patterns. At first, scientists thought it was noise thermal interference, a reflection of solar particles, or perhaps the instrument's own sensitivity reacting to deep space static. But after weeks of data refinement, the signal persisted. It wasn't random. It carried a faint but deliberate structure, almost like a heartbeat across eternity. What Webb had detected wasn't just light. It was a pattern hidden within the oldest radiance in existence, one that suggested organization before time, a rhythm preceding the very birth of physics. Imagine that, a universe humming before it was born. Some theorists began calling it the primordial pulse. The concept was haunting an echo of a universe that might have once lived and died before ours even took shape. The more scientists studied it, the more the data began to suggest that something incredible could be true. What if our Big Bang wasn't the first event in cosmic history? What if it was simply the latest in a sequence of cosmic awakenings, each universe born, expanding, fading, and giving rise to the next? If so, then the light Webb found might be the dying breath of the universe that existed before ours, the remnant energy of a creation older than time itself. Now close your eyes and imagine standing at the edge of that boundary, the invisible veil between our universe and what came before. It's silent, they're utterly still. No sound, no stars, just the endless dark. Yet, through that darkness, a flicker moves, a shimmer that holds the memory of everything that has ever been. This is the light Webb has seen, not bright or blinding, but soft, delicate, patient, a cosmic whisper saying, I was here before you. This discovery has forced cosmologists to reconsider everything about the birth of existence. If there truly was something before the Big Bang, then perhaps our universe is just one frame in an infinite film of creation, each frame blending seamlessly into the next. Some call this the conformal cyclic universe theory, a model where the end of one cosmos becomes the seed of the next. When all matter decays and only light remains, time loses its meaning, and the empty universe stretches endlessly until one day, light once again collapses and sparks a new creation, a circle, not a line, a rhythm, not a beginning. As Webb's data continued to pour in, researchers noticed the light had a specific spectral signature, one that didn't match any known atomic pattern. It wasn't hydrogen, helium, or any element formed in our universe. It was alien to existence as we know it. It carried information from an energy field older than matter, older than particles. The realization was staggering. This could be the afterglow of a pre-quantum state, a moment when even the laws of physics were still forming. And so, scientists began to wonder if time itself is not fundamental, but emergent, a property that arises only after energy stabilizes into matter. Before that stabilization, reality might have existed in a kind of eternal present, a timeless sea of potential. That's what the light seemed to reveal, a universe waiting to happen, hovering in a state beyond comprehension. Picture it, now the void before creation. There are no stars, no gravity, no distance, just the shimmering ocean of raw possibility, flickering softly in shades we cannot see. Then, without warning, the silence shifts. A wave forms in the fabric of nothingness, and suddenly, existence begins, not with a bang, not with chaos, but with a slow bloom of light, expanding gently outward until it fills everything. And deep within that first bloom lies the light Webb has now seen, still glowing, still moving, still whispering from before time began. It's hard to imagine that something so old, so impossibly distant, can reach us now. Yet every photon Webb captures is proof that the universe remembers. It remembers its own birth, its own moments of silence, and its own long journey into awareness. When we look up at the night sky, we are not just looking into space, we are looking into memory. The cosmos is a record, written in light. Somewhere in that vast record lies the story of everything. And maybe, hidden in those oldest rays, there's a message not in words or symbols, but in the very nature of light itself. A message that says the universe is endless, that beginnings and endings are illusions, and that creation is a continuous breath flowing through eternity. So as you listen, imagine yourself floating through that pre-time light. Let its calm rhythm slow your thoughts. Let the vastness wash over you like a cosmic tide. You are a part of that story, a brief flicker in the same light that once shone before time began. the same light that has crossed 14 billion years to reach your mind tonight. And as you drift toward sleep, remember, the universe doesn't end where we think it does. Beyond every horizon, there is always more mystery, more beauty, more time waiting to be born. Perhaps one day we'll see beyond the light web found. Perhaps one day we'll discover the next universe forming in the quiet, invisible sea that lies beyond our own. But for now, let the thought bring you peace. Because in the endless darkness of space, even before time itself, there has always been light. And so we continue drifting deeper into this ancient glow, into the soft radiance that predates everything you've ever known. As the James Webb Space Telescope collects more of this impossible light, researchers begin to notice something even more subtle in its structure: faint gradient, a shift so gentle it almost disappears into the noise, yet unmistakably real. It suggests movement, not the movement of matter or waves, but the movement of something older, something that existed before physical laws had hardened into place. It's as if this primordial light is flowing, slowly drifting across the darkness of precreation, not bound by time, not confined by gravity, but guided by a curvature of reality that no current model can explain. Imagine standing at the edge of a cosmic shore, watching a tide roll in from a realm that has no beginning. You can't see the water, but you can feel the rhythm, the quiet, persistent pull of something vast and eternal. That is the nature of this light. Scientists have started calling it pre-metric radiation, a term meaning that it existed before space could even be measured, before up and down, before near and far, before anything could be said to exist. And the more they study it, the more it becomes clear that this light doesn't behave like the cosmic microwave background. It doesn't spread evenly. It doesn't age the way light in our universe ages. It holds its structure, its softness, its whispering pattern, as if time has no influence over it. And that realization brings with it a profound possibility. Maybe time didn't start at the Big Bang. Maybe the Big Bang was simply the moment when time became useful, when the next phase of existence needed it to unfold. But before that moment, there may have been a different kind of reality, a timeless field of energy, where nothing yet separated itself from anything else. No matter, no borders, just a single, continuous presence. Webb's data hints that this presence may have had a texture, a faint fluctuation, like ripples on the surface of a sleeping ocean. These ripples might be echoes from a previous universe collapsing into silence. Or they might be vibrations of a deeper cosmic medium that has always existed, never beginning, never ending. And as you listen, imagine yourself drifting through that medium, floating weightlessly across a landscape with no distances. Every direction feels the same. Every moment feels identical to the last, because moments have not yet been invented. And yet, you can sense that something is happening there very slowly, like the first breath of a universe preparing to awaken. From this field of unformed potential, tiny seeds of structure begin to appear. Not stars, not atoms, not particles, just tiny asymmetries, little imperfections in the smoothness of the pre-time ocean. These imperfections, gentle and soft, are what eventually give rise to everything: gravity, matter, galaxies, life. And at the heart of each imperfection lies a fragment of that primordial light, still glowing, still drifting, still carrying the memory of the endless calm that came before creation. Webb has captured those fragments. Each photon it detects from this era is not just ancient, it is older than age itself. It has existed in a state beyond what minds can fully imagine, preserved across eons because timeless things cannot decay. And when scientists realized this, a profound silence fell across the research teams. They weren't just studying light, they were witnessing the last surviving traces of the universe's dream before it woke up. A dream made of stillness, a dream made of warmth without heat, a dream where existence and non-existence were the same. As you sink deeper into this thought, you may feel the slow unraveling of noise inside your mind, the soft fading of the day's thoughts, the gentle dimming of the world around you. Because this story is not just about the cosmos, it's about the quiet that lies beneath everything, including your own awareness. Just as the universe once rested in a timeless calm, you too can let yourself drift into that same ancient, peaceful state. And as the pre-time light continues its patient journey across billions of years, it reaches you not as a mystery to solve, but as an invitation to rest, an invitation to be still, an invitation to let your thoughts dissolve into a space where nothing is required of you. There, in that calm, the universe waited to be born. And here, in this moment, you can let your mind settle in the same quiet, the same warmth, the same timelessness that existed before anything else. You are listening to the oldest light in existence, and it is inviting you to fall gently, effortlessly into sleep. As we drift deeper into this journey, imagine yourself moving past the cosmic horizon, the invisible boundary where our observable universe ends. Beyond it, the light from ancient stars grows fainter until it dissolves into the soft, pre-temporal glow that James Webb has now uncovered. It's like stepping into a second sky, one older and quieter than the one we know. The darkness is not empty here. It shimmers faintly, as if breathing, slowly, calmly, like a sleeping giant that has been resting for billions upon billions of years. Scientists studying Webb's data noticed something extraordinary about this glow. Its temperature was impossibly uniform, smoother than any radiation that should have survived the chaos of the Big Bang. This uniformity led some researchers to propose that the light did not originate from our universe at all. Instead, it may have leaked into ours from the universe before us, slipping through the fabric of space-time during the first milliseconds of creation when physical laws weren't fully formed yet, when the cosmic barrier between before and after was thin, permeable, almost blurred. Think of it like ink spreading through water, soft, slow, graceful, merging without breaking, a smooth diffusion of ancient energy blending into our newborn cosmos. The idea alone is haunting. If true, it means that the universe we inhabit carries traces of a world that lived, evolved, and ended long before ours began. And now, as Webb peers deeper than any telescope before it, we are seeing that world's last breath. Some theories suggest that before our universe existed, there may have been countless others, an infinite ladder of cosmic births and endings, each leaving behind a faint signature, a subtle fingerprint etched into the deep background glow. Perhaps this light Webb detected is not just a leftover from a single ancient universe, but the combined radiance of many, layered together like translucent veils draped across eternity. When Webb captured those ancient photons, scientists realized they were holding something beyond rare. These particles had survived everything: the collapse of a prior universe, the birth of ours, the expansion of cosmic space, the formation of galaxies, the death of stars, the rise of planets. And now, finally, after an unimaginable journey, they arrived at a metal mirror floating in the silent vacuum. And from there, they reached you, your eyes, your thoughts, your imagination. You are witnessing the final echo of a universe that no longer exists. This alone is humbling. But what makes it even more mesmerizing is that the light carries variations, small, delicate ripples, so subtle that only a telescope as advanced as Webb could see them. These ripples may be the footprints of primordial structures, patterns in the pre-time light that hint at forces that shaped reality before matter was born. Some think these ripples could be evidence of pre-geometric patterns, subtle arrangements of energy that eventually crystallized into the laws of physics we know today. Imagine that, the rules of reality slowly forming like frost on a cold window, gravity expanding outward like a whisper, quantum laws settling into place like dust drifting to the ground, time beginning to flow, soft at first, then speeding up, stretching, becoming the river we know. And through all of this, the ancient light continues to glow, untouched, unchanged, older than the concept of age. As you relax deeper, imagine floating within that golden haze. You feel neither heavy nor light. There is no direction, no up or down, no left or right. Everything is calm. Everything is slow. Everything is suspended in a gentle state of becoming. In this place, you are not separate from the universe. You are woven into it, a tapestry of unimaginable age. Scientists have begun to wonder whether consciousness itself might be connected to this deeper reality. If the universe existed in a timeless state before the Big Bang, then perhaps some form of fundamental information existed to something that cannot decay, cannot vanish, something that survives across universes. Maybe the universe remembers, not just through light, but through the structure of space itself. And in some quiet way, maybe we are part of that memory. Webb's discovery has also sparked philosophical questions that go far beyond astrophysics. If the universe existed before time, then what does beginning really mean? Are we living in a sequel to an older cosmic story? And if so, what happened in that earlier tale? What forces shaped it? What mysteries did it hold? And how many cycles of birth and rebirth has reality undergone? The thought is vast, but strangely comforting. It suggests that the universe is not a lonely accident, but part of a grand, eternal rhythm, an endless breathing of creation and dissolution. A cycle where every ending becomes a beginning, where every beginning carries echoes of what came before. As you breathe slowly, allow that rhythm to wash over you, in, out, soft, gentle, endless, just like the universe. There is no rush here, no urgency. Only the slow movement of cosmic time, stretching across ages beyond comprehension. You are safe within it, carried by it, and the light web discovered, ancient and delicate, is drifting around you like warm stardust. Some researchers have proposed that this light may even hold clues about dimensions beyond our own. If the pre-time universe operated under different laws, Perhaps it had different shapes, different symmetries, different forms of matter and energy. Webb has given us a small window into that otherness, a chance to glimpse a reality that is not just older than ours, but fundamentally different. A reality where space might curve in unfamiliar ways, where particles could flow through dimensions we cannot see, where the fabric of existence dances to a rhythm beyond our three-dimensional understanding. Imagine drifting through such a place, shapes forming and dissolving like mist, colors shifting in ways your eyes have never known, distances bending, folding, relaxing. Every moment feels infinitely slow, yet impossibly ancient. The light is warm here, gentle, soft enough to cradle your thoughts into stillness. In this space, there are no worries, no noise, no pressure, only the quiet hum of creation before creation. This is the world Webb has revealed. A universe older than time, older than physics, older than existence as we know it. And now, as you listen, you are floating through it, held, supported, and surrounded by the oldest glow in reality. As we drift even further into this quiet river of cosmic thought, imagine the universe not as a place filled with galaxies, but as a slow-breathing organism, expanding with each beat, whispering its oldest secrets into the fabric of time. Webb's discovery of light, older than our civilization, is not just a measurement, not just a data point. It is a message carried across billions of years. A message whispered long before stars learned to shine and long before atoms learned to bind themselves together. In the soft darkness of this moment, picture the infant universe wrapped in a veil of energy so dense and so bright that it erased every boundary. A universe where time moved like warm smoke rising in a still room, smooth and uninterrupted. When Webb tuned its golden mirrors to that almost unreachable past, it pressed its gaze against a fog of primordial light, the kind of glow that comes not from stars, but from the universe's first awakening. It's like finding the heartbeat of creation itself, still echoing gently, even though the body has long since changed beyond recognition. As you inhale slowly, imagine that light drifting toward us, older than galaxies, older than the cosmic web, older than the very patterns that shaped the Milky Way. It passed through epochs of silence, crossed the vast nothingness between clusters, skirted the edges of invisible filaments of dark matter, and then continued, untouched and unchanged, so that one day, a telescope orbiting a small blue planet could finally receive it. And now, in this soft, quiet moment, you and that ancient light are connected. Webb found something unusual in its tiny ripples frozen into the glow. Ripples that tell the story of quantum fluctuations magnified into cosmic architecture. The same fluctuations that eventually became everything you've ever seen in the night sky. Scientists stared at those ripples and knew immediately that they were older than any star, older than any galaxy, older than any civilization that would one day look up and wonder. They were the fingerprints of the universe before it became the universe, before physics stabilized, before matter cooled, before space even decided how fast it should expand. And as you let your breathing soften and your thoughts drift like dust floating in a beam of dim starlight, you can feel how vast this timeline truly is. Imagine entire civilizations rising and falling in the blink of a cosmic eye. Imagine the Earth spinning through ages of ice and fire, while that single, ancient beam of light continued on, unbothered by extinction or evolution, or the quiet struggles of a species learning to understand the stars. Webb's sensors captured something strange in that light patterns, suggesting that the very first structures of the can simply imagine the universe not as a distant mystery, but as a breathing presence all around you, holding you in its ancient calm, inviting you to float with it through the darkness that cradled the first light ever born. And somewhere out there, in that darkness, the faint glow continues, older than stars, older than time as we know it, traveling endlessly, gently, patiently, waiting for someone else in some other distant future to discover it and wonder all over again. The light that James Webb detected, the one that seems impossibly old, behaves like a message stretched thin by billions of years of cosmic expansion. And when we study this faint signal, we find that it is not chaotic or random. There is a pattern woven through it, as if the universe left behind a quiet signature of its earliest motions. Scientists analyzing the data noticed subtle fluctuations that appear far too structured for something emerging from such a violent, newborn cosmos. These ripples might represent temperature variations, density differences, or even the first seeds of what would later grow into galaxies, clusters, and superclusters. But the strange part, the part that has scientists reconsidering the timeline entirely, is that the imprint appears older than even the earliest cosmic microwave background models predict. It is as if the universe held onto a memory that predates its own first heartbeat. One of the leading theories suggests that the universe, before the Big Bang, as we define it, could have existed in a different state, one that did not explode outward but transitioned gently, like water turning into vapor. If this is true, then the light James Webb may have captured is a remnant of that transition, a whisper from a cosmic era where time itself behaved differently. In these long, patient stretches of observation, the telescope collects photons that have been traveling longer than any planet, star, or galaxy has existed. They come to us faint and fragile enough that a slight distortion or interference would erase them completely. Yet somehow, against every odd, they survived the immense dark stretches of cosmic history, carrying with them the earliest architecture of everything. This kind of discovery changes how we imagine the universe's beginning. Instead of a sudden flash from nothing, the story becomes more layered. Perhaps there was a before. Perhaps the universe emerged not from emptiness, but from a previous cosmic cycle, passing down faint traces embedded in ancient radiation. If this light truly predates the earliest known periods, then it may serve as evidence of a universe far older than we have estimated. It suggests a continuity in existence, an unbroken thread running through cycles of creation and collapse, expansion and contraction, silence and awakening. The galaxies forming shortly after this period, the ones that James Webb sees as tiny smudges of red-shifted light, might not be the first galaxies at all, but the survivors of an even earlier cosmic structure. Their strange arrangements, their unexpected maturity despite their extreme distance, lend weight to the idea that something existed before our universe as we know it. Some researchers propose that these early objects are echoes of a prior cosmos, their fingerprints faintly pressed into the newborn universe, like a pattern left behind in soft clay. If so, then the faint, ancient light is not merely illumination, it is inheritance. This inherited structure becomes clearer when we map the distribution of the oldest galaxies Webb can detect. They do not appear scattered randomly. Instead, they align along invisible filaments, channels of gravity carved into the fabric of space long before stars ever ignited. These channels suggest that the universe had already formed a framework, a cosmic scaffold, prior to the earliest period predicted by standard cosmology. This framework is subtle enough to escape earlier telescopes, but detailed enough for Webb's infrared sensors to reveal. The more scientists examine it, the more they see patterns that should not exist so early in time, patterns requiring more time to form than the age of the universe ought to allow. Some astrophysicists propose that this anomaly points to new physics forces or fields that operated differently in the earliest fractions of existence. Others suggest that the expansion of the universe may have been slower at first, giving structures time to assemble before accelerating rapidly later on. There are even theories that the speed of light itself may have been different in the earliest epochs, allowing information and energy to spread more quickly across the primordial universe. Each possibility opens a new avenue, a new way of thinking, all sparked by a small stream of ancient photons that somehow survived the unfathomable ages. But perhaps the most intriguing possibility is the one based on a concept known as the cosmic bounce. In this view, the universe is not a singular creation event, but part of an endless cycle of expansions and contractions. When one universe ends, it collapses inward and then rebounds into a new expansion, leaving behind faint traces of its past self, traces that might appear as unusually old light. If the James Webb Telescope has truly observed such a remnant, then it means our universe has a lineage, a parent, you might say, whose final moments were preserved in the background radiation, like a final breath drifting across the boundary of time. When we imagine this, the universe suddenly seems far less lonely. Not a single isolated event surrounded by nothingness, but part of a larger tapestry, a vast chain of cosmic rebirths where energy and structure transition from one existence to the next. This idea is not only scientifically compelling, it carries a sense of calm continuity. It suggests that even the universe is part of a natural rhythm, a slow and steady pulse that has been beating long before stars, galaxies, or even matter itself existed. This faint, ancient light also reveals something else. The early universe was not as uniform as once believed. There were pockets of uneven density that grew into vast cosmic landscapes. Even in its earliest phase, space was shaping itself, forming the foundations of all future complexity. And if these foundations existed earlier than expected, then the timeline of cosmic evolution must stretch farther back than our current models allow. This extends the age of structure, formation, the flow of cosmic history, and the depth of time itself. The light that James Webb uncovered is more than a measurement. It is a messenger from a time when matter itself was still learning how to gather, how to cool, how to settle into the first delicate forms that would one day evolve into galaxies, stars, planets, and the foundation for everything familiar. Imagine a universe so young that temperature dominated over structure, a universe filled not with objects, but with potential. Within this early haze, the first waves of density began to rise like slow tides, pushing primordial matter into subtle ripples that would guide every future shape. These faint patterns, too gentle to see with any ordinary eye, traveled across unimaginable distances until Webb caught their whisper. By studying the grain of this ancient light, scientists glimpsed the earliest map of cosmic architecture, a blueprint older than any galaxy. And in this blueprint, they found a few lines that shouldn't exist, patterns that formed too early, too sharply, as though something accelerated the universe's order before the universe was truly ready. If this early structure is real, it forces us to reconsider the beginning of everything, not the Big Bang itself, but the delicate seconds and minutes that followed the era when energy cooled into matter and matter cooled into atoms. These newly observed hints suggest that the cosmos may have been seeded with a kind of complexity, almost like the grooves of a record waiting for the needle of time. It doesn't imply design, but suggests that the physical laws guiding creation might contain deeper layers than we imagined, layers that organize themselves ahead of time, layers that shape the flow of expansion long before anything becomes visible. The thought alone adds a soft kind of wonder to the mind, as though the universe grew out of a hidden rhythm older than light itself. Webb's sensors, designed to detect faint heat signals, registered a glow that reaches back to when the universe was only a few 100 million years old. But in the data, scientists detected something far stranger, light that doesn't match the expected age, brightness, or structure of anything from that era. Some of these signals appear to mature, too organized, almost like the fingerprints of galaxies that shouldn't have existed yet. In cosmic terms, they are ancient children who grew up too fast. It raises a question that lingers quietly in the background of every deep space observation. What if our timeline of cosmic formation is incomplete? What if the universe began creating complexity earlier than the models predict? Webb's findings open the door to possibilities that reshape the thresholds of cosmic time. Consider how delicate the early universe must have been. Tiny fluctuations in temperature and density would determine whether a region of space expanded into emptiness or collapsed into the seed of a star. The discovery that some early light behaves like it comes from mature structures suggests that either the universe evolved faster or something unknown helped guide that evolution. The idea is subtle, not alarming, just a gentle nudge toward deeper curiosity. Perhaps dark matter clumped earlier than expected. Perhaps dark energy behaved differently in the beginning. encouraging certain regions to cool and organize faster. Or perhaps the laws that shape the universe have a flexibility we have not yet understood, bending slightly in the intense conditions of early creation. This ancient light also serves as a reminder of scale. Every speck of brightness Webb collects has traveled for billions of years, crossing expanding space while stretching thinner and softer with every passing epoch. And yet, even after such a journey, it still holds a memory of its origin. It is astonishing to imagine how persistent this ancient light must be, how determined, in a way, to survive across endless darkness, to bring with it a message from a time long before stars existed. When scientists analyze it, they're not just capturing data, they're listening to the universe's earliest whisper about how it became what it is now. One of the most intriguing patterns discovered within this light is a series of fluctuations that resemble the kind seen in much later galaxies. These patterns show regions of condensed matter that appear to organize for the era they belonged to. If accurate, it would imply that the cosmos formed its massive structures, the pillars of galaxy clusters and cosmic filaments, far earlier and more efficiently than current theories allow. This doesn't challenge the Big Bang, but enriches it, as though the universe was more dynamic, more self-organizing, and more capable of rapid transformation than previously assumed. Scientists also found strange anomalies in the spectral fingerprints of the ancient glow. Some wavelengths appear stretched far beyond expectation, while others seem unusually strong, as if they were emitted by sources far brighter than any early cosmic object should have been. These anomalies hint at something extraordinary, perhaps. There were early eruptions of energy, early collapses of matter into dense regions, or unknown processes generating heat in ways we have yet to understand. Each anomaly is gentle, subtle, but meaningful, a tiny deviation that invites a new chapter of exploration. What makes this especially calming to think about is the slow, graceful way the universe evolves. Nothing rushes, nothing leaps, everything unfolds in vast, sweeping arcs of time. Even the anomalies Webb detected took billions of years to reach us, drifting through expanding space with a patience beyond imagination. And now, as Webb senses them, they transform from ancient memory into present knowledge, helping us understand not only what the universe was, but what it has always been capable of becoming. These findings also hint at the possibility that the early universe may have been more varied than we imagined. Instead of a uniform glow slowly condensing into form, there may have been pockets of rapid evolution, regions where conditions aligned just right to create bursts of early complexity. These early pockets could have grown into the first stars, or even into exotic structures that no longer exist today. The thought that the universe once held forms we cannot yet imagine is not frightening, it is soothing, in the way deep mysteries often are. It reminds us that creation is broader than our models, more intricate than our predictions, and more patient than our curiosity. The light that James Webb uncovered is more than a measurement. It is a messenger from a time when matter itself was still learning how to gather, how to cool, how to settle into the first delicate forms that would one day evolve into galaxies, stars, planets, and the foundation for everything familiar. Imagine a universe so young that temperature dominated over structure, a universe filled not with objects, but with potential. Within this early haze, the first waves of density began to rise like slow tides, pushing primordial matter into subtle ripples that would guide every future shape. These faint patterns, too gentle to see with any ordinary eye, traveled across unimaginable distances until Webb caught their whisper. By studying the grain of this ancient light, scientists glimpsed the earliest map of cosmic architecture, a blueprint older than any galaxy. And in this blueprint, they found a few lines that shouldn't exist, patterns that formed too early, too sharply, as though something accelerated the universe's order before the universe was truly ready. If this early structure is real, it forces us to reconsider the beginning of everything, not the Big Bang itself, but the delicate seconds and minutes that followed the era when energy cooled into matter and matter cooled into atoms. These newly observed hints suggest that the cosmos may have been seeded with a kind of complexity, almost like the grooves of a record waiting for the needle of time. It doesn't imply design, but suggests that the physical laws guiding creation might contain deeper layers than we imagined. Layers that organize themselves ahead of time. Layers that shape the flow of expansion long before anything becomes visible. The thought alone adds a soft kind of wonder to the mind, as though the universe grew out of a hidden rhythm older than light itself. Webb's sensors, designed to detect faint heat signals, registered a glow that reaches back to when the universe was only a few 100 million years old. But in the data, scientists detected something far stranger: light that doesn't match the expected age, brightness, or structure of anything from that era. Some of these signals appear too mature, too organized, almost like the fingerprints of galaxies that shouldn't have existed yet. In cosmic terms, they are ancient children who grew up too fast. It raises a question that lingers quietly in the background of every deep space observation. What if our timeline of cosmic formation is incomplete? What if the universe began creating complexity earlier than the models predict? Webb's findings open the door to possibilities that reshape the thresholds of cosmic time. Consider how delicate the early universe must have been. Tiny fluctuations in temperature and density would determine whether a region of space expanded into emptiness or collapsed into the seed of a star. The discovery that some early light behaves like it comes from mature structures suggests that either the universe evolved faster or something unknown helped guide that evolution. The idea is subtle, not alarming, just a gentle nudge toward deeper curiosity. Perhaps dark matter clumped earlier than expected. Perhaps dark energy behaved differently in the beginning, encouraging certain regions to cool and organize faster. Or perhaps the laws that shape the universe have a flexibility we have not yet understood, bending slightly in the intense conditions of early creation. This ancient light also serves as a reminder of scale. Every speck of brightness Webb collects has traveled for billions of years, crossing expanding space while stretching thinner and softer with every passing epoch. And yet, even after such a journey, it still holds a memory of its origin. It is astonishing to imagine how persistent this ancient light must be, how determined, in a way, to survive across endless darkness, to bring with it a message from a time long before stars existed. When scientists analyze it, They're not just capturing data, they're listening to the universe's earliest whisper about how it became what it is now. One of the most intriguing patterns discovered within this light is a series of fluctuations that resemble the kind seen in much later galaxies. These patterns show regions of condensed matter that appear to organize for the era they belonged to. If accurate, it would imply that the cosmos formed its massive structures, the pillars of galaxy clusters and cosmic filaments far earlier, and more efficiently than current theories allow. This doesn't challenge the Big Bang, but enriches it, as though the universe was more dynamic, more self-organizing, and more capable of rapid transformation than previously assumed. Scientists also found strange anomalies in the spectral fingerprints of the ancient glow. Some wavelengths appear stretched far beyond expectation, while others seem unusually strong, as if they were emitted by sources far brighter than any early cosmic object should have been. These anomalies hint at something extraordinary, perhaps. There were early eruptions of energy, early collapses of matter into dense regions, or unknown processes generating heat in ways we have yet to understand. Each anomaly is gentle, subtle, but meaningful, a tiny deviation that invites a new chapter of exploration. What makes this especially calming to think about is the slow, graceful way the universe evolves. Nothing rushes, nothing leaps, everything unfolds in vast, sweeping arcs of time. Even the anomalies Webb detected took billions of years to reach us, drifting through expanding space with a patience beyond imagination. And now, as Webb senses them, they transform from ancient memory into present knowledge, helping us understand not only what the universe was, but what it has always been capable of becoming. These findings also hint at the possibility that the early universe may have been more varied than we imagined. Instead of a uniform glow slowly condensing into form, there may have been pockets of rapid evolution, regions where conditions aligned just right to create bursts of early complexity. These early pockets could have grown into the first stars, or even into exotic structures that no longer exist today. The thought that the universe once held forms we cannot yet imagine is not frightening, it is soothing, in the way deep mysteries often are. It reminds us that creation is broader than our models, more intricate than our predictions, and more patient than our curiosity.